Now, I'm sure some of us can agree that we love rock and roll. However, most of us can also agree that we don't love it when we step on a rock and roll our ankles. Okay, how's that for a segue into talking about the ankle? Pretty good? All right, enough of the bad opening lines. Let's talk about the joints of the ankle and the foot. The ankle joint, or tibio-talar joint, is a hinge-type synovial joint located between the distal ends of the tibia and the fibula and the superior part of the talus, which are the three main bones of this joint. The main articular components of this joint are the trochlea and the body of the talus, which articulates medially with the medial malleolus of the tibia and laterally with the lateral malleolus of the fibula. In a nutshell, the tibia and the fibula are bound together by the strong tibiofibular ligaments, and together their respective malleoli form a bracket-shaped socket which is covered in hyaline cartilage. This socket is known as the malleolar mortis, and is where the pulley-shaped trochlea of the talus fits. The malleolar mortis is bounded posteriorly by the inferior part of the posterior tibiofibular ligament, superiorly by the articular surface of the tibia, with the medial and lateral walls being the medial malleolus and lateral malleolus respectively. The joint capsule of the ankle joint is thin anteriorly and posteriorly, but is supported on each side by a series of strong ligaments. Its fibrous layer is attached superiorly to the borders of the articular surfaces of the tibia and the malleoli, and inferiorly to the talus. By contrast, its synovial layer is loose and lines the fibrous layer of the capsule. Now, the supportive ligaments reinforce the ankle joint. Laterally, there's the lateral ligament of the ankle consisting of three completely separate ligaments which help prevent inversion of the ankle. First, there's the anterior talofibular ligament that extends anteromedially from the lateral malleolus to the neck of the talus. Second, there's the posterior talofibular ligament which runs horizontally, medially, and posteriorly from the malleolar fossa to the lateral tubercle of the talus. And third, there's the calcaneofibular ligament, which passes postero-inferiorly from the tip of the lateral malleolus to the lateral surface of the calcaneus. And medially, you guessed it, there's the medial ligament of the ankle, also known as the deltoid ligament, which stabilizes the ankle joint during eversion and prevents subluxation of the joint. This ligament attaches proximally to the medial malleolus, from where it fans out, attaching distally to the talus, calcaneus, and navicular via four adjacent and continuous parts: the tibionavicular part, the tibiocalcaneal part, and the anterior and posterior tibiotalar parts. The main movements of the ankle joint are dorsiflexion and plantarflexion. Dorsiflexion of the ankle is produced by the muscles in the anterior compartment of the leg, and namely the tibialis anterior, extensor digitorum longus, and extensor hallucis longus. Plantarflexion of the ankle is produced by the muscles in the posterior compartment of the leg, including the gastrocnemius and soleus in the superficial subcompartment, as well as the muscles of the deep subcompartment such as tibialis posterior, flexor digitorum longus, and flexor hallucis longus. Now, because the thicker anterior part of the talus is held in the mortis during dorsiflexion, the joint is more stable in dorsiflexion, and less stable during plantarflexion, because it's the narrow posterior part of the talus that is held more loosely in the mortis. Finally, the arterial supply of the ankle joint is derived from the malleolar branches of the fibular and anterior and posterior tibial arteries. And nerve supply of the ankle joint derives from the tibial nerve and deep fibular nerve. Okay, now before the joints of the foot kick in, you know the drill. Let's take a break and review the main components of the ankle joint. Okay, so some of the main joints of the foot include the subtalar joint, transverse tarsal joint, other intertarsal joints, tarsometatarsal joints, metatarsophalangeal joints, and interphalangeal joints. Let's start out with the subtalar joint, which can be defined in two ways. First, the anatomical subtalar joint. This joint is a single synovial joint between the slightly concave posterior calcaneal articular surface of the talus and the convex posterior articular facet of the calcaneus. The clinical subtalar joint includes the anatomical subtalar joint, plus the talocalcaneal part of the talocalcaneo-navicular joint, which are separated by the strong interosseous talocalcaneal ligaments that lie in the tarsal sinus. The clinical subtalar joint is used instead of the anatomical subtalar joint description alone to describe the functionality of this joint, because both the subtalar joint and the talocalcaneal part of the talocalcaneo-navicular joint act together, forming a single functional unit. The subtalar joint undergoes inversion, primarily thanks to the tibialis anterior and tibialis posterior muscles, as well as eversion primarily carried out by the fibularis brevis and the fibularis longus. Next, the transverse tarsal joint is a compound joint formed by two separate joints aligned transversely, the talonavicular part of the talocalcaneo-navicular joint and the calcaneo-cuboid joint. At this joint, the midfoot and forefoot rotate as a unit around the hindfoot. Let's take a look at those joints of the midfoot and forefoot. There are intertarsal joints between the other tarsal bones as well as the tarsometatarsal joints between the tarsal bones and the metatarsals. All of these joints permit slight gliding movements. The metatarsal phalangeal joints, which are located between the metatarsals and phalanges, allow for flexion, extension, and some abduction and adduction. Finally, the interphalangeal joints found between the phalanges allow for some flexion and extension, like when you're wiggling your toes. Go ahead, try it now. Alright, that's enough, because we need to discuss the major ligaments of the plantar aspect of the foot. First, the plantar calcaneo-navicular ligament, also known as the spring ligament, extends across and fills a gap between the anterior margin of the sustentaculum tali and the inferior margin of the posterior articular surface of the navicular. This ligament supports the head of the talus, transfers weight from the talus, and also aids in maintaining the longitudinal arch of the foot. Then there's the long plantar ligament, which passes from the plantar surface of the calcaneus to the groove of the cuboid, with some of its fibers extending to the bases of the metatarsals. The long plantar ligament is also important in maintaining the longitudinal arch of the foot. And finally, the plantar calcaneo-cuboid ligament, or the short plantar ligament, which extends from the anterior aspect of the inferior surface of the calcaneus to the inferior surface of the cuboid. And, as expected, it's also involved in maintaining the longitudinal arch of the foot. Now, like we've just mentioned a couple times, we've been hinting at something called the arches of the foot, which helps support the numerous joints of the foot through activities like walking, running, and jumping. There are 3 arches on each foot, forming a triangle, with the base of the triangle at the toes and the tip at the heel of the foot. The base is formed by the transverse arch, whereas the 2 sides are formed by the medial longitudinal arch and the lateral longitudinal arch. Because of their shape, the arches are able to act as a spring, bearing the weight of the body and absorbing the shock produced during locomotion. These arches are relatively elastic, so they can be flattened when standing, only to regain their curvature when weight is removed. Okay, so first, the transverse arch of the foot is located in the coronal plane of the foot, and it is formed by the bases of the metatarsals, the cuboid, and the 3 cuneiform bones. Second, the medial longitudinal arch, which between you and me is the more important of the longitudinal arches, is composed of the calcaneus, talus, navicular, 3 cuneiforms, and 3 medial metatarsals. And third, the lateral longitudinal arch, which we still love just as much even if it's not as important, is flatter and rests on the ground during standing, and is made up of the calcaneus, cuboid, and lateral 2 metatarsals. Now, the arches are also supported by 4 successive fibrous layers, which, from superficial to deep, include the plantar aponeurosis, the long plantar ligament, the short plantar ligament, and the spring ligament. Muscles also help maintain the curvature of the arches. For example, the transverse arch receives muscular support from the fibularis longus and tibialis posterior, which help maintain its curvature. The longitudinal arches receive support from flexor hallucis longus and flexor digitorum longus, with the tibialis posterior and tibialis anterior also playing an important role in supporting the higher medial longitudinal arch. And ta-da, we're done. But before we recap, let's try and recognize the joints and arches of the foot. Alright, as a quick recap, the ankle joint is a hinge-type synovial joint located between the distal ends of the tibia and the fibula, and the superior part of the talus, which sits in the malleolar mortise. The joint capsule of the ankle is supported on each side by the lateral and medial ligament of the ankle. Ankle joint movements include dorsiflexion and plantar flexion. The subtalar joint and the transverse tarsal joint are two of the major joints of the foot, and are mainly involved in the inversion and eversion of the foot. The most important ligaments of the foot are the plantar calcaneonavicular or spring ligament, the long plantar ligament, and the plantar calcaneocuboid or short plantar ligament. The foot also has 3 bony arches, supported by other fascial layers and muscle tendons.